Okay, for 7.5, it's a pretty brief lesson. We take the postulate of angle, and we then apply it to two other theorems, similarity theorems, side angle side and side side side. Side angle side just says that if an angle of one triangle is congruent to the other angle and the sides that are including it are proportional and the angles of the triangles are similar. Notice how the ratio of 3 to 6 and 4 to 8 is the same. The other side theorem for similarity is that if the two sides are similar and in proportion, then the triangles are similar. Now, do we need to know that all three are? It would help, but in a triangle situation, if two sides are in proportion, the third side is almost guaranteed to be. Here's a proof. We know that the given information is that AX and XC are proportional to BX and XD, and our job is to prove that AB is parallel to DC. Take a second and complete that proof now. By filling in the blanks here, I'm sure you got to the point where you could find two angles to be congruent based on the fact that two triangles were congruent, and then from the two triangles being congruent, you were only able to do that based on the fact that you know that the sides were proportional from the given, and also the fact that AXB and CXD were congruent by vertical angles. So once you had side angle side and then the other angles are congruent, you could prove that they were parallel because of the alternate interior angles theorem. Can you determine similarity based on the information you see here? If you can, what triangle is similar to the other? In number 1, we have the triangles to be not similar, and the reason is because the sides are not proportional even though we have vertical angles are congruent. 16 and 16 creates an isosceles triangle, but we can see here that there's no isosceles triangle for triangle SUT. Number 2, the triangles are congruent, and CBA is similar to FGH for side similarity. Try one more. In question number 3, they are similar for side angle side with the vertical angles and then proportional sides MV and VU and LV and VU, MV and VT. Over here, they are similar for angle. We see two angles and we know right away, as long as we name the corresponding angles with the vertices, we are similar. On your worksheet, you can answer questions 1 through 6. Number 7 was the proof from this slide right here. So that one should have already been completed. And finally, you have 8 and 9 as proofs to do on your own. And you can bring them in for homework tomorrow.